Yes, it's working. Okay, so just to summarize, these are the things coming up, and we've got test 2 is now on the 21st. And the career papers, you can see here. So, like I said, just randomized. I suppose that if you want to negotiate with one another, like Zane might say, I want mine first and not last. You could go pay off Evan or something. I don't know. Up to you. But yeah, there it is. Okay, no other issues? Okay, so let's take a look at the homework that was supposed to be due today. And I'd be like, what? Homework? Okay, here we go. And yeah, it's so small. Let's make it big. There we go. So down at the bottom of our Moodle page, general assignments. Okay, it's not at the bottom. It's under assignments. Let's see, where is this? So you've got the apportionment Excel sheet that you know about, the MFT reflection paper, slip something in there. Give me a little bit more than a page, not too much though, because I got to read all these things. And I don't like to read. But then here, this is for class on November 7th. That's today. Oh, yeah. So that's today. Okay, so let's talk about these. Smallest. What's the smallest that the quota could be? So just to remind you, we're dealing with a weighted voting system. And whoops, why won't that just stop where I want it to? Well, that's the way it's going to be. So we've got a weighted voting system. We have a quota. We have 7 voters. And the quota represents how many votes you need to pass whatever measure. Yes, no. These are all yes, no things. Should we continue to do the insanity of daylight savings time changing over the clocks, or no? Yes or no? And then everyone votes. And if we get to the quota, then we can dispense of the stupid time change. And if everybody will be happy. You can tell what my opinion is about the time change. But anyway, so let's deal with this. First of all, what's the smallest that Q could be? What did you get for that?
22.
It's 22? How did you know 22 is the right number?
Because I added all of those up, divided by 2.
Okay, so if you add them all up, you get 43 or something? Yeah, it's a 43. And so the total number of votes is 43, so you got to have at least 22. And the reason why is if you had 21 as the quota, you could say, yeah?
I think it is 21. I think if you add them all up, it's 41. Yeah.
Wait, is that right? 8, 7, 15, 25. Oh, yeah, it is 41. It's 41. So, yeah, so 21. But whatever the situation is, if you have less than that half, like 20, then you could have a situation where someone says, I want to continue using the time change. Who's with me? 20 people say yes, or 20 votes. And then someone else says, I want to abolish the time change. Who's with me? And there's 20 votes for that. So you could have 2 competing measures that both pass, and that would be bad. Although there's lots of contradictions in our legal system, we try to avoid that. Very nice. So yeah, take total. So apparently the largest is 41 then, if we add these up. Okay. All right. So now these are the harder questions. When is no one going to have veto power?
I have a question. For the smallest, isn't it normally like a less than, or is it less than be equal to that number? Yeah, but if 21 is greater than 25, you can have half a person.
You can have half a person? You can't.
She's saying it should be 22, not 21.
Oh, no, it's 21. Yeah, it's 21.
How does that work?
Because you can't have half a person. So, okay, here, yeah, let's see. Here, I'll get it. Let's just a sec.
So would then be 21.
Here, I'll just, there's all my stuff here. Here we go. So wait, now I need this. I need to be able to see here. Okay, whoops. Why is this not like that? Oh, there it is. Hold on, just a second. Let me write it down. Okay, so Q 10, 8, 7, 5, 4, 4, 3. Okay, yeah, so we got 41 is the total. Let me write this down. Okay, we have total of 41, total. And so all we want for out of a quota is a number where you can say, if you have this many votes, the measure passes. And so if you have 41 votes, then 21 will provide a situation where you just barely pass. That is, just barely more than half. So yeah, we just want to, what's half? 20 and a half. and then we just push it up just a little bit. We don't have to add 1 to that. We just push it up a little bit. So half of this is 20 and a half. We want to be more than half. Doesn't have to be a full integer more than half, just more than half. So 21 is sufficient. And it's because 21 versus 20, if you have two coalitions, two groups, one of them with 21 votes, one with 20 votes, then you can say, okay, they win, they don't win. So 22 certainly would be, you could use that as a quota, but it's not, 21 is the lowest possible quota you can have to have something pass. All right, let's do veto power. Now that we got this up here, we can do this quickly. So veto power, what do you think of that? Yeah. 21 to 31 votes. So 31. So it's kind of like when you think of veto power, you're thinking of when do you absolutely have to have someone in order to pass a measure? And so we'll deal with this person as having, when would that person have veto power? And the only time that person would have veto power is if the quota was, say, 32. So if the quota was 32, all of these people could get together and vote yes, and they still wouldn't pass whatever it was that you'd have there. So all of these people are 31. So anything between 21 and 31, exactly what Reagan said, is going to be no veto. No one has veto power. And so with 32, though, now this person can thwart the will of the rest of the people by saying, no, I don't want this. Now, certainly they aren't a dictator. They can't automatically pass something just because they vote yes. But yeah, so it's 21 to 31. Very nice. Oh, what was the last question? Wasn't there one more? Only one voter have veto power. Yes. So yeah, because it could be that more than one. For example, if the quota was 41, then everyone has veto power. So does anyone see when you would only have, and the one person would be this person. So at 41, everyone has veto power. At 32, just that person has veto power. So what other things? You've worked it out? 32 to 38. Oh, what about 34? Doesn't the 8 have veto power at 34? Well, let's check it out to 38. Well, let's see. Let's do 34 votes just to see what happens. So with 34 votes, so the question is, someone has veto power if they can, by voting no, everyone else votes yes, they end up defeating a measure. So let's say it's 34. Let's see if maybe I'm confused about what's going on here. So if you have 34 as your quota and all of these people vote yes, does that pass or does it fail? Let's see, 10, 22, 33. Yeah, this is 33. And so if the quota were 44, the 8 could say, I don't like it. So it's actually just 32 and 33. The 10 has veto power. So it's kind of like, to figure out if someone has veto power, just take the total and subtract off that person. And if that person removed from the total is less than the quota, then that person has veto power. So 41 minus 10 is 31. So the 10 has veto power here. 41 minus 8 is 33, so the 8 has veto power here. If we bump this up one more, 41 minus 7 is 34, so 35 would give 7 veto power. So you have veto power if by withdrawing your vote, you end up causing the thing to fail. Is that it? Is that it? Yeah, that's it. That's it. Okay, great. That's it. So I don't need to collect this because we all did it, right? Good job. Okay, so today we need to deal with how we assess how much power someone has. There's two ways, two groups of mathematicians figured out ways of telling whether you have power. And I just want to remind you what I'm talking about here by going back to this situation. Here, I think we'd all agree that all three of these have equal power. Equal power. And then here in this situation, Lewis has more power. So Lewis, because she has veto power, has more power than Martinez and Watney. And then here in this situation, interestingly enough, they all have equal power. Just to remind you of this thing that we did last time. So we need to be able to say, well, how much power does Lewis have? How much power does Martinez have? How much power does Watney have in each of these situations? That's the goal. And so we'll take a look at two different methods, one today and one next week sometime. So the one today is called the Banzhaf Power Index. Banzhaf Power Index, just named after a mathematician, John Banzhaf. Here, I've got a picture of him. There he is. Back in the 50s or so, he came up with this. So basically, this is, in the 1900s, so the 20th century is when mathematicians started caring about voting as an actual, application of mathematics, because you have things like shareholder meetings. So there's, I guess, more people were realizing that there was mathematics to be done to explain some of what was going on in the apportionment situation, in voting situations, and then here in this weighted voting situation. So Banzhaf said, it's pretty simple. You just figure out who's critical, who's important. If you're important, if you could change the outcome by changing your vote, then you're important. That's all Banzhaf said. If you've got that amount of power, then we're going to call you critical, and then we're just going to count up how many times are you critical, and that's going to be how much power you have. So a coalition is just a group of voters who are prepared to vote for or oppose a particular motion. This happens in Congress all the time. The Democrats form a coalition. The Republicans form a coalition. They say, well, we're all going to vote this way, and then nothing gets done, right? Yeah, we can't get rid of the time change of anything. It's such a bipartisan. I think 80% of Americans say we don't like the time change. And I don't care if it's standard time, summertime, or winter time. You pick. I don't care. Just don't make me change my clock. Okay, a winning coalition is just a coalition that has enough votes to pass a measure. That's it. So let's take a look at an example. Let's see. We'll get to critical voter in a minute. But let's go to this, that vote where Lewis had, you remember Lewis, Watney, and Martinez on this mission to Mars when Lewis had veto power. So we'll come back to this slide in a minute, but here is the weighted voting situation. You have a quota of 3, and then here's Lewis, Martinez, Watney. There are 3 number of votes. So let's see, how much power does Lewis have? To do this, we need to name these people. And the standard thing is to name them P1, P2, and P3. Player 1, player 2, player 3. But as you're going to see a little later on, I'm going to use A, B, C for reasons that will become more obvious then. But for now, let's just use these 3. And what I want to know is what are the different coalitions. So I don't care if they're winning coalitions or not. Just what is a coalition? So here's an example. Everyone could vote yes. So basically, these coalitions is who's going to vote yes? Coalition. And once again, I don't care if these are winning coalitions or losing coalitions. I just want to know what are they so that we can practice coming up with a list of all of them. So we'll go around. I'll see if you can come up with your own coalitions. That's one possible coalition. And by the way, that's a winning coalition. So let's manage attendance, more tools, random. Randomize. Julia, do you have another coalition? Yeah, if they get together, and that's a winning coalition as well, isn't it? Because together they have enough votes to pass whatever measure you have there. All right, very nice. All right, Roston, do you have another coalition?
P1.
Just P1 all by himself, or herself, I guess, Lewis. Yeah, that's a losing coalition, by the way, because they don't have enough votes to win. Very nice. All right, we're almost done. Sydney, you got another one? P1, P3. All right, there's only 3 more. So let's see if we can get those. Reagan, do you have another one? All right, very nice. P2, P3. Ooh, I didn't leave a lot of room for the last two, did I? Okay, let's get the one more, and then Sarah, you can tell me the next one, and I'll do the last one. P2 all by himself, and then P3 sad, all the way at the bottom. So those are the coalitions. There are 7 coalitions. And when you have 3 voters, you will always have 7 coalitions. There's a formula. I'll bet you could figure out what the formula is. Can anyone think of what that formula would be? Of how many, like if I had 4 voters, that would be the test. If you know how many coalitions, so for 3 voters, there are 7 coalitions. What about 4 voters? Any thoughts? Here's a hint about the 4 voters. All 7 of these are coalitions for the 4 voters. Because if you have 4 voters, P1, P2, P3, P4, that's a coalition. These are all coalitions. Oh yeah, what do you think?
2 to the 4th minus 1.
It is, yeah, very good. 2 to the 4th minus 1, nice. So I was going to suggest you just take these and double them, and you get 14, because these are all coalitions. And then if you throw P4 into each one of these, you get new coalitions. And then you have to have the P4 all by him or herself. But yeah, it's 2 to the 4th minus 1. Another way to look at it is it's the number of subsets. So subsets, there are 2 to the 4th subsets of 4 voters. Subtract 1 for the empty subset because we don't care about the situation where no one votes. So yeah, 7 is 2 to the 3rd minus 1. The next one, 5, would be 2 to the 5th minus 1. So these numbers are not insurmountable. They're small enough that you could do this with 5 voters. I'm not going to make you. I have homework with 4 voters. I hope I didn't misspeak. There may be a homework with more. I'll check. I'll look at it before we leave. Okay, so we're doing good. So let's see. We've identified all the coalitions. As messy as my handwriting is, at least we've got them. Now we want to figure out which ones are winning coalitions, but I guess we kind of did that. So let's see. Here are our winning coalitions. I will highlight them. This is a winning coalition. This is a winning coalition. And this is a winning. Is that it? Are there any other winning coalitions? I think I've got them all. Okay, so we've got all the winning coalitions. Now what we have to do is we have to determine who is important in each of those coalitions. So let's go and talk about critical voters. So a critical voter is just a member of a winning coalition whose vote is essential for the coalition to win. That is to say, if that voter changes their mind, can they change the outcome of the election? Because that's where power is, right? Power is when you can say, I could change this, and if I change my vote, the outcome will change. So you better be nice to me. And by be nice to me, usually what these people do is they'll say, you vote for my measure and I'll vote for yours or whatever. So yeah, so you have power if you can basically change the outcome of an election single-handedly. So let's go back to this and figure out who is critical, who is important. So for these, I guess we can zoom in a bit because down here, those are not winning coalitions. So here are the winning coalitions. Technically, those are the only 3 we would have to write down, but it's best to list them all, or at least most of them. Probably the ones with a single voter you wouldn't bother with because no single voter is going to, if you don't have a dictator, no single voter is going to win. Okay, so who's critical? So let's take a look up here. And in this first election, or this first coalition, there are 4 votes total. So if P1 were to change their vote, then that would change to 2 votes, which would be less than the quota. And so P1 is critical up here. If P2 changed their vote, it would change the total from 4 to 3, which is still a winning coalition. So P2 is not critical. P3 similarly not critical. So see if you can figure out who's critical in the other 2 coalitions, and then we'll tally things up. All right, let me just restart the randomizer. Oh, you're not here. All All right, Audrey, do you know who's critical in this second coalition, the P1, P2? They're both, yeah, very good. Because if either one of these people, if Lewis changes her mind or Martinez changes his mind, either one of them, you're going to drop below. You're just barely passing. You've got just enough votes to pass. So they're both critical. Very nice. Okay, last one, and then we'll move on. Jaron, what do you think of this last one, P1, P3? Also, yeah, same situation if either one of these people changes their minds. Okay, so let's actually get the number. Let's tally this up. So P1 is critical 3 times, P2 is critical 1 time, and P3 is critical 1 time. And so if I had to evaluate using this, and this is a little different philosophy than the other method that we'll learn next week, but if we were to evaluate who has the power, P1 has 60% of the power, P2 has 20%, and P3 20%. And where I'm getting these is the total here is 5. So there's a total of 5 times that anyone is critical. And so you'd say, well, 60% of the time, or they have 60% of the power, according to Bandsap. It's not 60% of the time, it's 60% of the power. So there's Bandsap. All right, well, let's try this with another one of these. Let's see. Is this one good? Sure. Yeah, let's do this one. I think this one's good. I've got several to work with. Plenty of time. So see if you can set this up. Here there are 4 people, 4 players, and technically you don't have to write down all 15 of the winning or of the coalitions. For example, no one is a dictator, so I wouldn't write down the 4 individual P1 all by him or herself, P2 all by him or herself, and so on. So start with the winning coalitions and try to get them all. I guess we have to go down to pairs because P1, P2, that's a winning coalition, isn't it? So I'll give you a minute, see if you can write them all down. Excellent. Let's see how we did. So I'll get the first couple. I think that we probably all know that P1, P2, and P3 is a winning, or P4, sorry. If they all vote, unanimous. That's what would be ideal, isn't it? If everyone votes yes for something. Moving down though, what are the other winning coalitions? Well, here, I'll do the next one and then we can get someone else to speak into this. So that's obviously a winning coalition. In fact, can I just put down all the groups of 3? Is that the case that any group of 3 voters, let's see, if P1, P3, P4, yeah, that's winning. P2, P3, P4. Okay, I think all the groups of 3 voters are winning coalitions. So P1, P2, P4, P1, P3, P4, P2, P3, P4. Okay, so I think I got all of the most of them. There's a few more, so we should check on the pairs. Usually when I do this, if I'm trying to be efficient, then I'll start with the biggest coalition and then work my way down. And then starting on, when I get to the point where I have a losing coalition, I know that if I put weaker and weaker people into the coalition, it's still going to be losing. So I guess that's the thought process to make it as efficient as possible. So let's go through the 2-person coalitions. And the strongest one is P1, P2. and that one is a winning coalition. So you see what I'm doing here is I'll start with P1, P2, and then I'll work my way down. So Julia, what about the P1, P3? Does that one win? Yeah. Okay, so that one's winning as well. P3. All right, Sarah, what about P1, P4? No, it's not. Yeah, so that one's not. So I'm not going to put it in my list. I mean, if you were listing all the coalitions, there's 15 of them, you could put it down. Okay, so that doesn't work. Okay, now we seem to have exhausted most of the possible winning coalitions, but there's one more winning coalition. Does anyone see which one it is? You got it, Zane? 2 and 3 together, yeah. So it's good to sort of mentally at least go through, make sure we hit all of them. I mean, technically, the safest thing is to list every single coalition, but here I'm going to have to put P2, P3 at the top, just to, because I ran out of room at the bottom. I think that's everything. Does anyone see another? Are there any other? Oh, there is one more. Oh, no, there isn't. Never mind. I got excited for nothing. Okay. Yeah, I think that's it. But like I said, to be safe, you would probably want to list all 15, especially if you are doing this on a computer. I've seen computer implications or implementations of this where basically list them all off, figure out which ones are winning, and going from there. Yeah, this would be a cool project for like a computer science 1 course. Figure out how to do this, implement this. All right, so now your next job is to figure out who is critical in these. So each of these is a winning coalition. Who's critical? All right, maybe we'll just go around and see each one. So Roston, what about P2, P3? Who's critical there? So who, for P2, P3, the first one, who are both of those necessary to pass? Okay, so they're both critical. So we'll highlight both of them. They're both critical. All right, Zane, what about P1, P2, P3, P4? Who's critical there? None of them, yeah, because any one of them could leave and be like, who cares? You know, the motion's still going to pass. So no one is critical in that P1, P2, P3, P4. All right, onward. Evan, what about P1, P2, P3? Yeah, none of them are either. Even though, you know, so we don't care if any one of them changes their mind, still the motion will pass. All right, Sydney, what about P1, P2? I should mark these off since we've checked this one and this one. No one's critical. All right, so the next one down, P1, P2, P4. Who's critical there? All right, very good. So 1 and 2. So 1 is critical because if 1 leaves this coalition, we're left with just 5 votes, not enough to pass. And if 2 left the coalition, we'd be left with 6 votes, not enough to pass. But 4 is not critical because if 4 left the coalition, you'd have 9 votes, which is enough to pass. So you see the logic here, hopefully. Okay, Jaron, what about P1, P3, P4? Okay, so P1, similar, similar logic, right? So you have a similar situation. Very nice. Okay, we're up to Reagan. What about P2, P3, P4? P2 and P3, very nice. All right, we're almost done. Okay, so Julia, what about P1 and P2? Yeah, both of them are critical. All right, Audrey, what about P1, P3? They're both critical as well, yeah. All right, let's add them up. See who's got the power here. So P1, P2, P3, P4. So let's see if I tally these. 1, 2, 3, 4. Did I get 4 for P1? 1, 2, 3, 4. Weird. They're both the same. 1, 2, 3, 4, and then 0. Did I get that right? Huh. Interesting. So, even though you have different numbers of votes, these people all have the same amount of power That person has no power. So there's the according to Van 't Hoff, that's the situation, is that P1, P2, and P3, they all have 33 and a third percent. Okay, I'll just go with 33%. 1/3. That would probably be better. Oh no, where'd my thing go? There it is. I was trying to erase and thought I wanted to move forward. Yeah, so they all have 1/3. So I'll just do it this way: 1/3, 1/3, 1/3. 33 and a third percent. All right, beautiful. All right, I've got one more to take a look at, and then we will have to. Oh no, wait, is it one or two? There might be two more. There's one for sure, and I need to write this down because I have it, but it's 753111. Here, I'll put it over here. I've got it, but it's in the second section, the method that we're going to learn about next week. So 7 is the quota, 5, 3, 1, 1, 1. Okay, before we get started, let us note that this particular problem has, there's 5 voters. I probably should have had even more than that, but there's 5 voters. And so you would have to do 2 to the 5th minus 1, which is 31 coalitions. And that's a lot of coalitions, right? So, I mean, it's not even, if I should have picked even more. Well, I could always slap another 1 in there, couldn't I? No, yeah, why not? Yeah, no. Let's leave it the way it is. So, but I could put another voter here, and then you'd have 63 coalitions. That's way too many. You might be willing to do this. In fact, I've had students do something like this for me, and they write them all out instead of actually using some mathematical thinking. But let's use some mathematical thinking to figure out this one without having to write down all 31 coalitions. So to do that, I'm going to name these people P1, P2, P3, P4, and P5, but then I'm going to categorize the people. So these people, well, this one person has 5 votes. I'm going to call that category A, this is category B, and these are all category C. So here's why I'm doing this, is so that I can figure out the coalitions without having to list every single one of them. So winning coalitions, let's see, what do you need to win? So win, you can do this, A, B, C, C, C. As long as you have that, you're going to win. You're also going to win if you have A, B, C, C, A, B, C. And in fact, A, B. So those are all winning coalitions. But you could also have a winning coalition if you have A along with 2 C's, or A along with 3 C's. And I think that's it. So you might want to double check, because if you don't have A has veto power in this situation, doesn't they? Because if you get rid of A, there's not enough votes here to pass a measure. So I think I've got all the possibilities here, because B, C, 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 if you have a B along with 3 C's, not going to work. So notice that I've shortened this considerably, because this here, A, B, C, C, it actually represents three different coalitions, because it's person A, person B, and then 2 out of 3 of those. So that's actually 3 different coalitions that look like this. So I'll just do this. I'll just call this, there's 3 of these. There's only 1 of these. There are 3 of those. There's 1 of these. There's only 1 of these, but there's 3 of these. So you can see how even if you had even more, and in fact on your homework, one of the problems is going to have you sort of dissect a problem that has way more than this. You're not going to have to do the power index for it though. But if you have a bunch of people that have the same number of votes, you can condense all of the coalitions and just deal with them, it's in groups. So let's deal with all of these in groups, if you will. So in this case, A, here we go, I'll highlight these. A and B, no, just A. Just A is critical. Yeah, just A is critical. Here, just A is critical. Here, A and B are both critical. And here, A and B are both critical. You can double check if you don't believe me. Here, just A is critical. And here, all three of them are critical. Okay, so double check. I've got my winning coalitions kind of categorized. And then we're going to have to sort out some of these categories in just a minute. But this is a way of shortening the amount of work that one has to do this. So we can categorize, and now that we've got things categorized, we can count. Hopefully you believe me that there's three, if we were to write this out with P1, P2, P3, and so on, there would be three coalitions that look like this, three that look like this, and three that look like this. And so if you believe that, then out of all of the coalitions, it looks like all of them have A. Whoops. So A is critical 3, 6, 9, 12. 12 times. B will be critical 4 times. And each of the C's, now here's where things get a little bit dicey. We have to be careful with the C's. So each of the C's, each individual C, will be in 2 of the 3 of these. And if you need to, you can list them off. You'll have P1, P3, P4. I'll list them off just to show you P1, P3, P5, P1, P4, P5. So those 3 are being condensed into this. So you have to use a little bit of mathematical thinking here when you say, okay, how many of these for each of the C's, each of these C's will be in 2 of these. So notice that P3 is in 2 of them, P5 is in 2 of them, and P4 is in 2 of them. So each of the C's are going to have two times that they're critical. So anyways, in total, you have, I guess I'll put the power index up above. So player 1 has 12 times that he or she is critical. Player 2 has 4 times, and each of these people has 2 times that they're critical. Add that up, you get 22. So now you can write these as fractions. Player 1 has 12 out of 22. 12 22nds is the fraction of the power that player 1 has. Contrast that with players 3, 4, and 5 that have 2 out of 22. 2 22nds, or 1/11th of the power. And then player 2 is 2/11ths, apparently. So just wanted to sort of point out that you can do this, and certainly with one of the homework problems, if we were to do BANSAF, which we will next week, with that one, you'll need to sort of think about things as being all the same. So speaking of the homework, let us take a peek at it. Let me get it up here. I want to explain something about it that is might be a little bit confusing. So get this out of the way now, and then maybe you'll have a better shot at being able to do it. So you'll find this down here. It's kind of chunky. There we go. So I just have made up a few problems here. So a basic, simple BANSAF power index for this weighted voting system. A little bit more complicated weighting voting system. So once again, just find the BANSAF power index for that. And then slightly more complicated. So there's 3 just basic, doing what we just did. Won't take you too long, just to practice. Then the one that is going to be the one that requires a little bit more thought is the UN Security Council. Oh, and I have at the bottom helpful reference to online, since this isn't in the book that I made you get. So there's an online book that has a good sort of chapter describing this, and here it is. So there's the link. But on this last problem, UN Security Council, it has 5 permanent members. List them out there, and 10 non-permanent members. Those cycle through, so that Uganda will be on it, and then Albania, and so on. So every however many years, they cycle through the non-permanent members. So each country gets to be a non-permanent member on the Security Council every so often. So what I'd like to do is take this situation. Oh, and so the deal is 5 permanent members have veto power. So basically, you want to set up your voting system so that those 5 people have veto power, and the 10 non-permanent members don't have veto power, but they matter because for a motion to pass, you have to have how many votes? A motion? 9 members. 9 members must vote. So that's the way that the UN Security Council is set up. But in order to evaluate the power structure, what we're going to need to do is we're going to need to make this into a weighted voting system. So here's your job, your challenge, and it's not that hard. Is you're going to come up with a quota, and then you're going to have some number, we'll call it X. So X will be the weight for the permanent members. So we have 5 permanent members, we have the list here of those 5, and then 10 non-permanent members. Oh, I keep doing the wrong thing there. Okay, so we have 5 permanent members. We'll call them all X. And then, honestly, well, I could put a Y here for 10, so put 10 Ys. But when I've done this in the past, let's just make this easier on you. I believe that this does work if you just give all the non-permanent members 1 vote. So 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There. I know it looks so crazy, doesn't it? But here's your job, though, is you want to come up with, and there's multiple answers that work, but it's always nice to know what the minimal answer. Come up with a value of X. So what should X be? And there's 5 people that have that many votes. And then come up with a quota. And your job is to make sure that the players, so P1, P2, P3, P3, I can't speak and write apparently, there, those people, they should all have veto power. So whatever you choose for X, and you could do this guessing and checking, or you could use some math, maybe some algebra, I don't know. But whatever you use for X and whatever you use for Q, you should make sure that the 2 things that are correct for the UN Security Council, number 1 is each of these players, the X people, they should have veto power. And for something to pass, so the quota has to be set, I guess the quota, I'll just tell you this right now, has to be set so that 9 people are necessary. Oh, so that's going to be 5 X's plus 4 of these. Okay, so I kind of gave it away, at least part of it. So because you need 9 votes to pass, and you need, for sure, you need these votes, the X's. So you want the quota to be 5X plus 4. So anyway, you could do some experimentation. There's a little bit more algebra. I won't give away any more of it because it's kind of fun to figure it out on your own. But once you have that, then you can figure out how much more powerful the United States is than Uganda on the UN Security Council. And it's surprising how much more powerful, especially when you realize that Uganda only gets to be on the Security Council once every 12 or 15 years. I don't know how often. 10 countries out of 160, 70, I don't know. So yeah, it's every 17 years maybe, so it cycles. All right, so that's it. Yeah, I think that's it. Any other concerns, questions about what's going on over the next couple weeks? So I guess the exam won't be for until after. It's 2 weeks from today. Is that what we decided? 2 weeks from today? I've got it here on the PowerPoint. So let me just double check. So I wrote it down. And my job now is to also figure out the, no, that's not it. Where did I put this stuff? I have to figure, there it is. I have to figure out the career situation. Okay, yeah. So test, yeah, 2 weeks. 2 weeks from today is November 21st. So I'll fill this in the rest of the way for next time. All right, nothing else? We're good? All right, excellent. So hope you have a great day. Enjoy the sunshine. Oh, turn off this. Stop it.